All right, so if I have this rectangle and I continuously rotate it around W, what kind of solid will I form here? So again, W is going to stay where it is. I'm going to rotate this rectangle around and around and around and around W. What type of figure should I end up with? And we just ended this unit with these type of figures, so hopefully visually we can see this. So which solid would be formed here if I continuously rotate it around W? Think about rotating it around and around and around. If I got to bring up a visual, I can. What are we thinking here? A lot of talk here. 12 thoughts? Cylinder. Yep. Definitely going to have a cylinder here. If anybody has any questions why it would be a cylinder, let me know. Just because it's a rectangle doesn't mean rectangular person. All right, you got to keep rotating around W. How about 2? I rotated around that flagpole. I rotate that right triangle around the flagpole. What are we looking at here? I'm going to go quick. 10, what do we think? That's a cone. Yep, definitely a cone. Going to get that circular base. Looks like BC is going to be the radius. And we got a little vocabulary term we got to talk about here. An equilateral triangle's rotated around its median. What three-dimensional object? Real quick, since we are reviewing. Even though most of you can answer this without even knowing, I still want to review it. Equilateral, what do you know? Let's go through. Equilateral.
All sides are equal.
All sides are equal. And?
Angles.
All angles, meaning if I hear it's equilateral, I know all sides are equal, and because I know all the angles, can you figure out what each angle is? Again, nothing to do with this problem, but may come up in a couple days. What do I know about all the angle measures then? They're all equal, so they all equal how many degrees? 60 degrees. Good. 60, 60, 60. It's rotated around. Let's review that term. Median. Median. Anything before I review it you want to give me? What a median was?
Middle, right?
Yes. Starts at a vertice and is drawn to the what of the opposite side? Midpoint. Yes, it's drawn. Medians are drawn to midpoints. Okay, so that's a midpoint. So that's where I'm going to rotate it around. Again, it's still going to be the same. It's still going to be, the figure is not going to change. I just want to make sure we review those. And what do I end up with? What type of figure here? 9. This is going to go fold around, right? It's going to end up being a cone again, right? Because that's going to be a circle. Yep. Medians go to midpoints from a vertice. Medians. All right. Questions, comments? Okay. Next up, equations of lines. Always comes up for some reason. Equations of lines. Let's take a couple notes down below before we answer these questions. Here you go. A couple notes real quick down at the bottom. Parallel lines. If 2 lines are parallel, they have, somebody fill in the blank, type of slopes. 2 lines are parallel. They have blank type of slopes. Parallel lines. Parallel. 11. Thank you. Nice. Have same slopes, equal slopes. All right. There we go. Good start to the review. Same slopes. All right. Well, what if I change it up on you and now I say perpendicular lines? Perpendicular lines have for slopes. Do you remember this one? More, I need more than opposite though, because to me, opposite just means change the sign, but it's more than just, it is changing the sign. A little more. Kira?
Negative reciprocals.
Flip it too. Okay. Negative reciprocals. Good. Negative reciprocals. So if it's 3/4 a perpendicular line, negative 4/3. Flip and change the sign. Ready to roll? Okay, number 4. Slope of a line is negative 1/3. What's an equation of a line that could be perpendicular to it? All right, well, we know the slope's negative 1/3 for line L. What's got to be the perpendicular line slope then? We just went over they have to be negative reciprocal. So let's start there before I circle a choice. If negative 1/3 is the slope of L, slope of the perpendicular line, 2. Yep. 4. 3. Positive 3. Good. Everyone good on how I got positive 3? All right, now I have to figure out which choice has a slope of positive 3. And we are not just going to look at them. We need each of those choices to be in y equals mx plus b form. So you just can't look at it and wherever I see a 3, I'm going to circle. Because if you do that for choice 4, you're wrong. We need it into y equals form. So you need to now move everything over except for y and figure out which one's going to have a slope of positive 3. Number 1's out because that's going to have a slope of 1/3. Even when I move over the 2, it's going to have a slope of 1/3. 4 is out because when I move 3 over, I'm going to subtract it and then it'll have a slope of negative 3. So now I'm down to 2 and 3. Get y by itself and figure out which one's going to have a slope of 3. Move everything over, get y by itself. You got it. You got it. Expecting big things out of this group right here. Just got to put in the time. If the only time you're going to prepare is in class, we're in trouble. Remember, we're only looking for a slope of 3. I don't care what the rest of the equation is. I'm only looking for a slope of 3 here. All right, which one gives you a slope of 3? Out of those 2 that are left, 13, Charlie?
3.
Choice 3. Good work. Good work. Good work. Nice. Yep, you move the 9 over, it becomes negative 9, then you divide by negative 3. That's how you get the 3 out. Yep, good. Anybody, we're all right there? Okay, 5. Which equation represents, line parallel to this equation and passes through 1, 3. So what we're going to do first, we're going to write our equation like this is not multiple choice, like this would be in part 2, where I have to show my work. And then we'll look back and say, all right, which multiple choice is the best for it? So what do we got? Parallel, let me write this one out. Negative 2x plus 3y equals negative 4. All right, so first thing, what the heck's the slope of this line? And then we'll talk, what about a parallel line? So get this into y equals form for me. First step, 10, first step. Add 2x, everybody, over, good work. 3y equals 2x minus 4. Next step to get y by itself. 4.
Divide by 3.
Divide by 3, good work. All right, so in y equals form, 2/3 x minus 4/3. I don't care about the 4/3. Who cares? We're only looking for slope because we're dealing with parallel lines. So what's the slope of this line we just transformed? 12? 2/3. So what's going to be the slope of a line parallel to it? Parallel, not perpendicular, parallel to it. What's going to be the slope? 1? Anna?
2/3.
Also 2/3. Slopes are equal, a parallel line. So at least I know my new line is going to have a slope of 2/3. But now we got to figure out what's the new y-intercept if it goes through 1, 3. All right, here you go. Goes through 1, 3 now. So I'm going to take y equals mx plus b, and I'm going to solve for b. I need to know what that new y-intercept is. And I'm going to use the point it goes through, 1, 3. Plug in 3 for y equals my m 2/3 x 1. Everyone see where that 3 and 1 came from, the point it goes through. Now you guys are going to solve for b. Now solve for b. I plugged in 2/3 because the slopes were equal because they're parallel. Now I solve for b. We're going to have to move that 2/3 over, deal with the fraction. Oh well. So you move the 2/3 over. Hopefully you guys got 7/3 for b. 3 minus 2/3 gives you 7/3. How's that look, all right? All right, so the equation of this line, if I had to write it out on a part 2 question, y equals 2/3 x plus 7/3. Now you have to go back to the multiple choices. Take a look. Go back to the multiple choices and put each one of these into y equals mx plus b form and find out which one comes out to be 2/3 x plus 7/3. So I'll let you guys give a minute or two, distribute, and then move over the 3. All right, got to distribute first. Don't move over the 3 until the very last step. Distribute. And then figure out which one's going to be 7/3. If you want to find the y-intercept, make sure you plug it into y equals mx plus b. Solve for b. Which one gives you the 7/3 and the 2/3 for the slope? When you're ready, 13, Charlie. Okay. Well, I think I can eliminate. You guys can eliminate 1 and 3 because it looks like it's going to give you a slope of -3/2, right? So if I do, so this will be y plus 3 equals 2/3 plus 3, right? How do I move over that 3? I'm sorry, plus 2/3. How do I move over the 3? Subtracting it, right? And that's going to give me a negative y-intercept. If I do 2/3 minus 3 in my calculator, that should give me -7/3, I think. But what did we get as a y-intercept? Positive 7/3, right? So you see how it can't be choice 4 because I need positive 7/3. So it's going to be choice 2. Sure you're all right? Everybody else, are we all right? I don't know what happened there. And again, I'm just giving you guys a little, we don't have time to review this for 2 or 3 days. We got to keep moving, but it's going to be there. All right, pretty good shot that anything we're going over in this packet will be on there. Not everything, but pretty good shot. All right, going back to our days of partitions now. There's always one. All right, some always shows up somewhere, whether it's multiple choice or you got to show your work. So I got A is -6, -5. B is 4, 0. Give me point P that partitions it up into a ratio of 2 to 3. So we'll have to review the steps one by one. Everyone see how the use of the grid is optional? Not for us. It's not optional. You're going to use it, and I'll show you why at the end. All right, we're using it. This isn't optional for us. And if it doesn't provide you with a graph, you will have scrap graph paper on the back of your exam packet. Okay, the booklet that they hand you has your reference sheet and scrap graph paper at the end. Use it for the partition question. So go ahead and graph line segment AB. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. It's not optional for us. And I'll show you why at the end I don't want it to be optional. All right, if it's a ratio of 2 to 3, 2 to 3, I put both together, add them up. That means I need to divide AB into 5 congruent parts. Okay, 5 congruent parts. And you need to remember that 5 is huge. And I get that from the 2 to 3. All right, we do this. We're going to do this process once for the X coordinate. And we're going to do it again, same exact process, but to find the Y coordinate. Step 1, find the distance on the x-axis between the two. What's the distance on the x-axis between the two? You can count it on your graph, or you can go in your head, what's the distance from -6 to 4? Okay, -6 to 4, what's the distance on the x-axis? And that should be a distance of, what do we get, 10? Okay, so that's a distance of 10. You divide that, because I have to cut it up into 5 congruent parts, I divide that distance by 5. I'm going to cut it up into 5 congruent parts. So that tells me every time you want to cut it up into an equal part, you go 2 units every time. Not far from done yet. But where does that partition point? Does it have to stop after I do it once 2 units, twice 2 units? Do I have to do 2 units 3 times? Where's this point going to end up? Go back to the ratio, and I take a look at the first number. That's huge, 2. So I only have to do this twice. So step 2 is I'm going to go 2 units twice, because that's where my partition point has to be. I'm going to go 2 units, and then I'm going to go another 2 units, and I'll be at my partition point. So that tells me you're going to move 4 total units from your starting point. Okay, 4 total units from your starting point. So I go back, last step. I go, okay, where did I start on the x-axis? Where did I start? At what coordinate? Where did I start on the x-axis? I don't care about the y, just the x. Where did I start? At -6. Everyone, I started at -6. So from -6, I go over 4. And that lands me at -2 on the x-axis. Let's repeat it all, but for the y's now. Repeat it all again, but we're going to do it for the y coordinates. All right, find your distance between your y's. What's up? Yeah.
If you just find the x-axis, could you just like go right on the x-axis and then go like this?
If you graphed it correctly, yes.
Okay.
You know, my fear would be that maybe you graphed a point wrong, and now that point's wrong. Okay. All right, how many units away are your y coordinates? I believe they're 5 units away. So divide it by 5 again. So now instead of going 2 units every time like I did on the X, I'm only going to go 1 unit. So go up 1, go up 1. You're breaking it up every time you go up 1 unit. You do not change the number of times. It's always that first number in your ratio. Never change it. You don't use the second number. So I'm going to go once, 2 times for a total of 2 total units. And always go back to the original starting point on the y-axis. And our original starting point was what? -5? Nope. Yep, -5. So from -5, go 2 units up, and we end up at -3. So our partition point should be -2, -3, and this is why graphing is not optional for my students. That partition point should end up on your line. So that's why I want you to graph it. Make sure -2, -3, -2, 1, 2, 3 should end up on the line. Ready? 2 to a ratio of 2 to 3. That part should look bigger. All right, the 2 part should look smaller. All right, that's why I want you to graph it. All right, think you can handle this next one on your own? Same thing, it's just now a ratio of 2 to 1. So now we're breaking it up into 3 congruent parts. All right, see if you can get it. You guys can check as your point on your line. Make sure it looks like a ratio of 2 to 1. Open 2, 5 ends up being your point. And if you graph 2, 5, it does look like 2 to 1 because the first part of the segment's a little bit bigger than the second part. 6 divided by, for the x coordinate, 6 divided by 3 gives you 2. 2 times 2 is 4. And then -2 plus 4. Got to have these down because it's going to show. It's going to show. All right, here's how I'll end it. The problems I assign are just like the ones are the same topics we just went over. All right, it's not like you guys are going to be clueless. Oh, how did we do that problem from 5 months ago? These should be partitions, parallel perpendicular lines, and rotating figures around the line. All right, so why don't you start taking a look at those? It's only 5 problems. You guys know where the answer keys are now up on Classroom. Utilize them. All right, so these should look familiar here. It's just more practice from what we talked about today.